I want you to imagine that you're watching a marathon.
Okay, I've got the picture.
So there's this one runner who has been setting a solid, exhausting pace for hours. And then right at mile 20, when everyone else is basically hitting the wall, gasping for air, completely drained, this runner doesn't just keep their pace.
Right.
They start sprinting. Not like a gentle acceleration, but a full-blown sprint at twice their original speed.
I mean, that defies the basic laws of human biology. You'd assume you were hallucinating.
You would definitely be rubbing your eyes.
I see.
But we are watching that exact scenario play out right now, not on a racetrack, but in the incredibly complex, highly physical world of semiconductor hardware.
Yeah, and it's wild to watch.
Welcome to the deep dive. We've got a fascinating stack of sources for you today, including official earnings called transcripts, press releases, and this phenomenal analysis report from Morningstar Canada titled "Firm is Not Blinking."
That's a great title, honestly.
It really is. Our mission today is to decode this technological sprint that has Wall Street completely stunned. We are unpacking the explosive, record-breaking Q1 fiscal 2027 earnings of Marvell Technology.
Which is just a monumental shift we are looking at. The numbers coming out of this single company, well, they tell a much larger story about how the entire global data infrastructure is being physically rebuilt from the ground up to support artificial intelligence.
Exactly. And the sheer scale of those numbers is why we are dedicating this deep dive to you, our listeners. Because over the last 3 months, Marvell stock is up nearly 200%.
Which is just staggering.
And that Morningstar report we mentioned, they almost doubled their fair value estimate for the stock in one swoop, moving it from $130 up to $235.
Yeah, they didn't just tweak their model, they completely rewrote it.
Right. So our goal today is to figure out the mechanisms behind that leap. And more importantly, explain the staggering AI architecture that's actually making it possible.
Because we have to look at both the financial execution and the engineering reality. Right now, those two things are completely inseparable.
Totally. But before we jump into those mechanics, I do need to drop a quick mandatory disclaimer for everyone listening.
Always important.
Yeah. So all information and analysis discussed here are just to help everyone better understand the market and do not constitute investment advice. Investment involves risks. Please make sure to do your homework before entering the market or consult a professional financial advisor.
Right. It's a key distinction. We are here analyzing the physics and the market dynamics. We're not endorsing a specific portfolio move.
We are strictly staying neutral, just looking at the incredible engineering and market shifts.
Exactly.
So let's start with the raw financial reality because it really sets the stage for the technology. Q1 fiscal 2027 revenue from Marvell hit a record $2.418 billion.
Wow.
Yeah, that is up 28% year over year. And their non-GAAP earnings per share came in at 80 cents.
And just to clarify that non-GAAP figure for a second, because financial jargon can get a bit dense.
Please do.
So GAAP is the standard accounting rulebook, right? But non-GAAP strips out one-time costs like stock-based compensation or the immediate cost of acquiring another company.
Okay, so it gives a clearer picture of the actual day-to-day business.
Exactly. It gives analysts a much clearer view of the operational health and profitability. And an 80-cent non-GAAP EPS on that revenue shows incredibly healthy operations.
But the Q1 numbers, as strong as they were, they actually aren't what shocked the market.
No, it was the guidance.
Right, the forecast for what comes next. Q2 revenue is expected to hit $2.7 billion. For the full year, fiscal 2027, the outlook was raised to $11.5 billion.
A massive jump.
But the absolute bombshell that had analysts scrambling to rewrite their projection models was the fiscal 2028 outlook, which, by the way, correlates to calendar year 2027.
Right.
They raised their revenue outlook by a massive $1.5 billion, targeting a staggering $16.5 billion.
Which represents a 45% year-over-year growth. And you have to realize they are doing that off of an already elevated base.
Right, because usually growth percentages shrink as a company gets larger.
Exactly, just due to the law of large numbers. But Marvell is accelerating. The engine driving this is entirely their data center business. Right now, data center revenue makes up 76% of Marvell's total pie.
So it's basically the whole show.
Pretty much. And they expect that specific segment to grow by about 50% this year and then accelerate to 55% next year.
That's the part that feels like the marathon runner sprinting. I mean, hardware companies, historically, They're not supposed to scale their revenue curves like early-stage software startups.
No, definitely not.
Hardware takes years of research, fabrication, testing, deployment. You can't just, push an over-the-air update. So how is a massive physical manufacturing company pulling off 50% year-over-year growth at this scale?
Well, it points to a structural, foundational shift in the global economy. I mean, this isn't the normal semiconductor cycle where demand for PCs or smartphones just goes up and down.
It's something entirely different.
Yeah, this is driven by an unprecedented wave of cloud capital expenditures, or CapEx. The biggest tech companies in the world are pouring hundreds of billions of dollars into AI infrastructure.
And Marvell is right in the middle of it.
Exactly. Morningstar specifically noted that Marvell is crushing its targets because they offer a holistic portfolio. They aren't just selling one isolated component.
Right.
They are supplying the networking, the optical connections, and the custom compute chips. They are essentially building the central nervous system for the entire AI boom.
Okay, so if they're building the nervous system, we should probably understand how it physically operates.
Yeah.
Because when most of us hear networking, we just think of our home Wi-Fi router.
Right, or maybe plugging an Ethernet cable into a laptop.
Exactly.
Yeah.
But to grasp this 55% growth in data centers, we have to understand how these AI supercomputers are actually built.
The scale is almost unimaginable compared to home networking. In the earnings call, Marvell's CEO Matt Murphy framed their strategy around 3 specific networking domains: scale out, scale across, and scale up.
Okay, so those are the 3 pillars of modern AI architecture.
Basically.
Let's take those one by one. The sources describe scale out as the traditional front-end network. And Marvell is apparently dominating the space with their 51.2T and upcoming 100T and 200T Ethernet switches. Alongside this technology they call PM4 DSPs.
Right.
So what exactly is a PM4 DSP doing in a data center?
Okay, think of a standard digital signal like a light switch. It's either on or off, a 0 or a 1.
Right, binary.
Exactly. That's how traditional networking sends data. A PM4 DSP, which stands for Pulse Amplitude Modulation 4-level digital signal processor, changes that simple light switch into a dimmer switch with 4 distinct readable levels.
Oh, wow. So you have 4 options instead of 2.
Yeah, and by doing that, you can encode and transmit twice as much data in the exact same time frame over the exact same physical wire.
That is incredibly efficient.
It is, and Scale-Out uses this technology to connect thousands of individual servers together. When you ask ChatGPT a question on your phone, the Scale-Out network is what receives that request from the outside world and routes it to an available server inside the building.
Got it. So scale out is the building talking to the outside world and the servers talking to each other.
Right.
But then we hit this new frontier mentioned in the reports, scale across. The analysis highlights that AI clusters have grown so massively that they physically cannot fit inside a single building anymore.
No, they are hitting a hard ceiling on local power grids and physical real estate.
Because if you need to string 100,000 AI processors together to train a new massive language model,
no single municipal power grid can support that without browning out the surrounding city.
literally taking down the grid.
Yeah. So these tech giants are forced to split the supercomputer across multiple data centers. Half of the brain is in one facility and the other half might be 10 miles down the road.
But they still need to process calculations as a single unified brain. That sounds like a logistical nightmare. I mean, the latency alone, just the time it takes for data to travel 10 miles, wouldn't that normally bottleneck the entire system?
It's one of the hardest engineering challenges in the world right now. And Marvell is attacking this through the data center interconnect, or DCI, market.
Okay, so how fast are they moving data across these distances?
They are pushing data transfer speeds from 400 gigabits up to 1.6 terabits per second across these vast distances.
1.6 terabits.
Yeah, and because this physical space limitation is only going to get worse as AI models get larger, Marvell's DCI business alone is projected to hit $1 billion in annualized revenue by fiscal 2028.
Just from connecting different buildings together.
Just from that.
Okay, so we have scale out, handling the front door, and scale across acting as the high-speed highway between different buildings. That leaves the third domain, which is scale up. The sources describe this as the back-end network, where custom AI chips, XPUs, talk directly to each other, completely bypassing the traditional Ethernet network.
Right, it's pure, unadulterated speed between the processing cores themselves.
So if we visualize a single data center as a human body, scale up is the microscopic internal neurons firing back and forth inside the brain itself.
Yes. It is incredibly dense and insanely fast.
And then scale out would be the nervous system connecting that brain to the hands and eyes, interacting with the environment and the users.
I like that analogy, yeah.
And scale across is like developing high-speed telepathy between two entirely different brains located miles apart, forcing them to think the exact same thought at the exact same millisecond.
That's a really great way to map it out mentally. And the reason these quote-unquote brains need to communicate so intensely comes down to a shift in how AI is being used. The earnings call placed a heavy emphasis on a trend called agentic AI.
Right. They mentioned we are moving past one-shot inferencing.
Yeah. Up until now, AI has mostly been a simple call and response. You ask an AI to write an email, it thinks for a second and spits out the text. One shot.
But agentic AI is different.
Very. Agentic AI is autonomous. You don't give it a prompt, you give it a complex, multi-step goal.
Like what?
Let's say you tell it to plan a 2-week vacation to Japan, book the flights based on my calendar, and schedule restaurant reservations based on my dietary restrictions.
Okay, that's a single prompt that requires dozens of different actions.
Exactly. The AI agent has to break that goal down into subtasks. It has to query a calendar model, search external flight databases, talk to a translation model for the restaurants, and constantly verify its own work.
So it's talking to itself, basically.
It might loop and query other parts of the AI cluster thousands of times just to fulfill that one single user request.
Which means the volume of internal data flying back and forth inside the data center isn't just growing linearly, it's going exponential.
It skyrockets, and that makes the network itself the single most critical bottleneck in the entire AI ecosystem. I mean, you can buy 100,000 state-of-the-art AI chips, but if the network connecting them is slow, those multi-billion-dollar chips just sit idle waiting for data to process.
Wow. So if the volume of data traffic is expanding that violently, how are they physically moving it? The sources point to a literal revolution happening at the hardware level. The industry is moving away from copper wires and shifting to literal beams of light.
Yeah, it's the optics revolution. Marvell's interconnect business, which is heavily reliant on optics, is expected to grow over 70% this year alone. They are deploying technologies like co-packaged optics, CPO, and near-packaged optics, NPO.
Wait, hold on. Why are we suddenly abandoning copper?
Yeah.
I mean, we have used copper wires to connect computers since the dawn of the internet. It's cheap, it's reliable, and we know how to manufacture it perfectly.
That's true.
Is silicon photonics just a fancy buzzword to pump up investor excitement, or is there an actual physical wall that copper just can't cross?
It is a hard wall built by the laws of physics.
Really?
Yes. As you push terabits of data through a copper wire, you encounter electrical resistance. That resistance generates heat. So to push the electrical signal faster and further, you have to pump in more power, which creates even more heat. Ah, I see. And in an AI data center, power consumption and cooling capacity are your absolute limiters. Copper simply requires too much power and runs way too hot to connect these massive AI clusters at the speeds required today.
So it's not just that light is faster, it's that light is colder.
Exactly. Photons don't generate the kind of frictional heat that electrons do in a wire. They can carry vastly more data over much longer distances using a fraction of the power.
That makes a lot of sense.
And Marvell isn't just experimenting with this. They noted on the call that they have accumulated over 15 billion hours of field data on their silicon photonics platforms over the last 10 years.
15 billion hours. That level of proven reliability is massive. I mean, if you are a hyperscaler like a Google, an Amazon, or a Microsoft, and you are building a $5 billion data center, you are not going to risk the entire facility on an experimental technology.
No, absolutely not. You want the safest, most battle-tested optical connections available, and Marvell has a decade-long head start on that field data.
And they seem to be doubling down on that lead with their recent acquisitions, specifically bringing in companies like Celestial AI and Polariton.
Yes, very strategic moves.
The Polariton acquisition really caught my eye because of a technology called plasmonics. The Morningstar report mentions that plasmonics offer up to 10 times higher bandwidth than current silicon photonics, reaching speeds over 1 terahertz.
Which is incredibly fast.
Right. But how does a plasmonic surface actually manipulate light differently to get a 10x speed boost?
So it solves a fundamental problem of scale. A particle of light, a photon, is physically quite large compared to the microscopic electrical pathways etched into modern computer chips.
Okay.
Trying to run a standard light wave directly into a processor is sort of like trying to drive a massive cruise ship down a narrow back alley.
That's not going to fit.
Right. Plasmonics is a branch of material science that solves this by interacting the light with electrons on the surface of a metal. It effectively compresses the light wave, turning it into surface electron waves called plasmons.
So they shrink the light to fit the alleyway.
Exactly. They compress it, squeeze it through the microscopic optical highway on the chip, and it allows them to pack vastly more data pathways into a tiny physical space without interference.
That is wild.
It is cutting-edge material science, ensuring the physical infrastructure can actually handle the AI models of tomorrow.
Well, speaking of the AI models of tomorrow, we cannot talk about Marvell without talking about the 800-pound gorilla in the room, which is Nvidia.
Oh, yeah. You can't ignore them.
The sources outline a massive expanded partnership between the two companies, featuring three main pillars. First, optics using Marvell's silicon photonics for that scale-up network. Second, NVLink fusion integration. And third, AI RAN, which marries AI with 5G and 6G telecom networks.
Right.
I really want to unpack that second pillar, though, NVLink fusion. What is NVLink, and what does this integration actually mean for the industry?
Okay, so NVLink is NVIDIA's proprietary super high-speed communication protocol. It's basically the language their GPUs use to talk to each other incredibly fast.
Okay, makes sense.
Now, NVIDIA obviously dominates the AI compute space, but the hyperscalers building these data centers, they don't want to be entirely locked into one vendor. So companies like Amazon and Google are developing their own custom AI chips in-house.
But they still need to use NVIDIA's networking infrastructure because it's the industry standard.
Right. And those custom chips, they don't naturally speak NVLink. So NVLink fusion integration is essentially a universal translator.
Oh, I see.
Yeah, it allows these hyperscalers the flexibility to mix and match their own proprietary custom-built chips with NVIDIA's merchant infrastructure. And Marvell is providing the highly specialized networking silicon that bridges those two distinct architectures, ensuring they can seamlessly share data without bottlenecks.
Which acts as a perfect bridge to the custom silicon side of Marvell's business. Designing world-class optical tech and acting as a universal translator is phenomenal engineering. But it's only half the battle.
True.
If a company can't actually get these chips manufactured during a severe global AI chip shortage, all of these projected billions in revenue are just fantasies on a spreadsheet.
And the projections are certainly aggressive. Marvell expects their custom compute business to more than double by fiscal 2028.
Right.
And Morningstar analysts are projecting that custom segment alone could reach an astonishing $10 billion by fiscal 2029.
$10 billion from custom chips alone. That is nuts.
It is.
The sources break that growth down into three areas. Existing XPU programs, something called XPU attach, and a massive new Tier 1 XPU program that is currently ramping into volume production.
Right.
Let's decode those. What exactly is a Tier 1 XPU?
So in industry terms, Tier 1 refers to the absolute largest cloud providers on Earth. We are talking about the massive hyperscalers.
Heavy hitters.
Exactly. And an XPU is a catch-all term for custom processors, whether that's a TPU for tensor processing or an NPU for neural processing. So a Tier 1 XPU program basically means Marvell has co-designed a highly specific proprietary AI chip for one of the biggest tech giants in the world, and they are now moving from the design phase into mass manufacturing.
Okay, and what about XPU attach? The sources mention this includes memory expanders and CXL technologies.
Right, so CXL stands for Compute Express Link. And to understand why it's a big deal, think of traditional computer architecture, like an office building where every individual processor has its own private filing cabinet of memory.
Okay, I'm with you.
If processor A needs a piece of data that is stored in processor B's cabinet, it has to send a request, wait for processor B to find it, and then wait for the data to be sent over.
Which creates terrible latency.
Exactly. It's very inefficient, especially when they need to share data constantly. CXL changes the entire architecture. It turns all those private filing cabinets into one massive open-plan shared library.
Oh, wow.
Yeah, it allows different processors, accelerators, and memory components to directly access a shared pool of memory simultaneously without having to ask permission from each other.
That sounds vastly faster.
It is.
Yeah.
XPU attach refers to the silicon Marvell makes that facilitates this high-speed shared memory environment, ensuring the processors are never starved for data.
The engineering is brilliant, but, we come back to the physical reality of the supply chain. The entire AI industry is severely constrained right now.
Yes, that is a huge factor.
Every tech company on the planet is fighting for limited fabrication space at foundries like TSMC in Taiwan just to get their silicon printed.
Yeah.
How is Marvell ensuring they actually have the physical chips to sell?
Well, according to the earnings call, they're executing a highly aggressive, multi-year supply strategy.
What does that look like?
They aren't just placing orders quarter by quarter, they are sharing deep 5-year demand forecasts with their key suppliers. But more importantly, they committed $1 billion in cash prepayments this fiscal year, specifically to lock in future manufacturing capacity.
$1 billion in cash, essentially just to save their spot in line.
Exactly.
When I saw that number, it struck me as the ultimate flex of confidence. You don't hand over $1 billion in non-refundable prepayments based on a hunch that demand might be there.
No, absolutely not.
You do it because you have the ironclad purchase orders from your customers already in hand. They're putting their money exactly where their guidance is.
It goes right back to the title of that Morningstar report. Firm is not blinking. In what is arguably the highest stakes poker game in the history of the tech sector, Marvell isn't blinking.
Because they have the cash to back it up.
Right. They have an incredibly strong balance sheet, generating a record $639 million in operating cash flow in Q1 alone, so they can afford to use that cash as a weapon. They're buying the single most valuable commodity in the AI space right now.
Certainty of supply.
Bingo. If you are a cloud provider halfway through building a multi-billion-dollar AI cluster, you cannot afford for your network switches or your custom processors to be delayed by 6 months.
Every day of delay costs millions in lost compute time.
Exactly. So Marvell is using their cash reserves to guarantee to those customers. We have secured the fabrication space. We will have the exact parts you need exactly when you need them. That mitigates massive execution risk for the hyperscalers.
It's an incredibly comprehensive strategy. They lock down the physical manufacturing capacity, they design the optical highways to solve the heat problem, and they build the custom chips to do the actual thinking.
Yep.
It's basically an end-to-end capture of the infrastructure market.
And they are doing it all simultaneously while maintaining strong profitability metrics. It is really a masterclass in market positioning.
This has been a deeply technical journey through the architecture that is quietly powering the AI revolution. To do a conversational recap, to sort of synthesize all these sources into the major takeaways for our listeners.
Good idea. I think we can distill it into 4 major structural shifts.
Let's hear them.
First, Marvell is experiencing unprecedented accelerating financial growth. We are looking at a revenue guidance jump of $1.5 billion for fiscal 2028, strictly fueled by the hyperscale AI data center boom.
Second, the physical footprint of AI is evolving because of power constraints. Clusters are too big for one building, forcing the industry to move beyond traditional scale-out networks into to scale across linking buildings miles apart and scale up, linking the chips directly with zero latency.
Third, the future of massive data transfer is undeniably optical. Copper has hit a hard physical wall regarding heat and power consumption. Light is the answer, and Marvell is commanding this transition with proven silicon photonics, cutting-edge plasmonics, and deep integration with Nvidia's NVLink standard.
And finally, they are aggressively securing their own future. By pouring $1 billion into supply chain prepayments, they are guaranteeing they can fulfill an exploding backlog of custom silicon orders. They are selling their customers absolute certainty in an uncertain supply chain.
It's really a comprehensive lock on the plumbing of the AI era.
And just a quick reminder for everyone tuning in, while the engineering breakthroughs and these massive financial leaps are thrilling to unpack, we remain entirely neutral here. We are analyzing the market shifts and the advanced physics behind modern data centers, not telling you to go out and buy a stock.
Right. Always do your own research.
Always.
It's about understanding the mechanics of the world around us. And, before we wrap up today, I want to leave you with one final thought to mull over.
Renee, what is it?
We talked extensively about agentic AI, the autonomous models that continuously query themselves to solve complex problems.
Right, the infinite loop of data.
Exactly. Think about the long-term implications of that. If AI models begin querying and talking to other AI models autonomously in a continuous loop across facilities that are miles apart, the primary bottleneck of human innovation is no longer computing power.
Because we can always build larger facilities and put more chips.
Exactly. The bottleneck becomes the network itself. We are rapidly approaching a reality where the sheer speed of light itself becomes the limiting factor in how intelligent AI can ultimately become.
Wow. The speed of light is the limiting factor for artificial intelligence. It really puts the scale of this engineering into perspective. It turns out that marathon runner at mile 20 isn't just sprinting against the competition. They are trying to outrace light itself. Thank you so much for joining us on this deep dive. We'll see you next time.